Hi everyone, so today I'll be going through the 2019 Further Maths Exam 2, the Recursion and Financial Modelling section. So question 7, Phil is a builder who has purchased a large set of tools. The value of Phil's tools is depreciated using the reducing balance method. The value of the tools in dollars after n years can be modelled by the recurrence relation shown below. Use recursion to show the value of the tool after 2 years, V2 equals $48,600. So to do this question, basically we have to show how to get to the $48,600 after 2 years. So to do this, we've got to use recursion as the question tells us. So we know V0, the initial value of his tools, is $60,000. So therefore V1, according to the rule, would be 0.9 times 60,000. If you put that on your calculator, you'll get 54,000. So to find V2, we use the value of V1, 0.9 times 54,000, which equals $48,600, as stated in the question. 7b, what is the annual percentage rate of depreciation used by Phil? So to do this, we know in the question it says the value of Phil's tools is depreciated using the reducing balance method. So that means the value of R, which is 0.9 as stated in the question over here, would have been found by using the formula 1 minus R on 100, because it's we're using the reducing balance method. We know the value of R is 0.9 as stated in the question over here, because this is the value of R. So if you sub 0.9 in R, 0.9 equals 1 minus R on 100. The value of R over here is representative of the annual percentage rate of depreciation. So if you solve for R on your small r on your calculator or on your calculator, you'll get R equals 10, which is representative of the percentage rate of depreciation. So therefore, the annual percentage rate of depreciation used by Phil is 10%. 7c, Phil plans to replace these tools when their value first falls below $20,000. After how many years will Phil replace these tools? So first of all, to do this question, I would convert the recurrence relation given in the question to an nth term relation. So we know that the rule for an nth term relation is Vn equals Rn times V0. So if we sub the values of R and V0 into this equation, just by the way, V0 is representative of the initial value of the tools. So Vn equals R is 0.9 to the power of n times V0 is 60,000. So if we sub Vn as 20,000, we'll find the value of n. So sub Vn is 20,000. 20,000 equals 0.9 to the power of n times 60,000. If you put that on your calculator and solve for the value of n, you'll get n equals 10.42. So if we say the value after 10 years, if we say Phil replaces these tools after 10 years, that would be incorrect, because after 10 years the value of Phil's tools hasn't actually fallen below 20,000. It's only after 11 years, if you round this up, will the value of Phil's tools actually fall below $20,000. So therefore, after 11 years, Phil's tools will fall below $20,000. 7d. Phil has another option for depreciation. He depreciates the value of the tools by a flat rate of 8% of the purchase price per annum. Let Vn be the value of the tools after n years in dollars. Write down a recurrence relation in terms of V0, Vn plus 1, and Vn that could be used to model the value of the tools using this flat rate depreciation. So to do this question, we know that the rule of a recurrence relation using the flat rate method of depreciation would be V0 equals something, Vn plus 1 equals Vn. In this case, it's flat rate depreciation, so it would be minus D. So we know V0 is $60,000 because that's the initial purchase price of Phil's tools. Vm plus 1 equals Vn minus D. So we have to find what the value of D is. So to find the value of D, we know that Phil depreciates the value of his tools by a flat rate of 8% of the purchase price per annum. So that means 8 on 100 times 60,000, which is the purchase price, would give us the value of D. To put that on your calculator, and you'll get 4,800. So therefore the value of D is 4,800, and that would be your recurrence relation. Question 8. Phil invests $200,000 in an annuity from which he receives a regular monthly payment. The balance of the annuity in dollars after n months, AN, can be modeled by the recurrence relation. What monthly payment does Phil receive? So basically, this recurrence relation over here models his annuity after n months. So this is A0 over here is the initial value of the annuity, and 3,700 is the amount that Phil receives from the annuity every month. So that's basically Phil's payment. So the monthly payment Phil receives is $3,700, as we can see over here from the recurrence relation. 8b, show that the annual percentage compound interest rate for this annuity is 4.2%. So to do this, we know that the value of R is 1.0035, and we know that the formula for R is 1 plus little r divided by compounding periods on 100, because it says in the question the annual percentage compound interest, so we know that compound interest is present. So we basically sub the values of R and P into the equation. So we know the value of R is 1.0035, which is given in the recurrence relation. So 1 plus little r is what we're trying to find, divided by P, which is 12 on 100. So basically, since the question is a show that question, we actually have to show how we're gonna find the value of R. So to do this, you solve algebraically on 100, which equals 1.0035 minus 1. We put the 1 on the other side, so it becomes minus 1. And then R on 12 would become 100 times 1.0035 minus 1, which equals R, and then R would equal 12 times that, 12 times 100 times 1.0035 minus 1. So basically the value of R would equal, you put that on your calculator, and the value of R should get 4.2% per annum. 8c, at some point in the future the annuity will have a balance that is lower than the monthly payment amount. What is the balance of the annuity when it first falls below the monthly payment amount? Round your answer to the nearest cent. So the way I do this is just with reiteration on your calculator. So I just enter the initial value as 200,000, which is given in the question. 200,000. That's 200,000. Hit enter, and then multiply it by 1.0035. 1.0035 minus $3,700, and then you just reiterate on your calculator, and we'll just keep reiterating until the value of the annuity is lower than the monthly payment. And we know that from the question the monthly payment is $3,700. So we just got to wait until the value of the annuity is less than that monthly repayment. Here we're getting closer now. 3,778. So therefore, the balance of the annuity when it first falls below the monthly payment is $92.15. 8d, if the payment received each month by Phil had been a different amount, the investment would act as a simple perpetuity. What monthly payment could Phil have received from this perpetuity. So basically we know that a perpetuity always has the same amount, and basically if you put money into a perpetuity, the amount the person investing the money receives. So for example, Phil, if he invested the $200,000 into a perpetuity, the amount of money he'd receive each month is just the interest. So we know that the interest is 4.2% per annum compounding monthly. So write it like that, 4.2% divided by the compounding periods on 100 times the amount he invested into the bank, which was $200,000. And you put that on your calculator and you'll get $700. So therefore his monthly payments were $700 if he had invested this money into a perpetuity. Question 9. Phil would like to purchase a block of land. He will borrow $350,000 to make this purchase. Interest on the loan will be charged at the rate of 4.9% per annum, compounding fortnightly. After 3 years of equal fortnightly repayments, the balance of Phil's loan will be $262,332.33. What is the value of each fortnightly repayment Phil will make? Round your answer to the nearest cent. So to do this, we need to get up our financial solver. So if you have a CAS calculator, it's menu finance solver if you didn't know. So we got to insert the values over here from the question. So we know that Phil will borrow $350,000 to make this purchase. So you sub $350,000 in the present value section. Interest on loan will be charged at the rate of 4.9% per annum. So 4.9% per annum, compounding fortnightly. So compounding fortnightly is 26. After 3 years of equal fortnightly repayments, the balance of Phil's loan will be, so it says after 3 years of equal fortnightly repayments, so that's after 3 years of fortnightly repayments. So if you do that, it will be 78. So 3 years of fortnightly repayments, which gives us 78. And then we know the future value will be $262,332.33 because that's the balance of Phil's loan after 3 years. So put that in negative because that's the amount Phil still owes the bank on his loan. So put to negative 262,332.33. So we basically just have to find the fortnightly repayment. If you put that on your calculator, you'll get negative 1704.03 round to 2 decimal places. So therefore, Phil's fortnightly repayments are $1,704.03. 9b. What is the total interest Phil will have paid after 3 years? Round your answer to the nearest cent. So we have to calculate the interest Phil has paid over the past 3 years of his loan. So I just written the formula over here to find out how much interest Phil will have paid. So basically, it's the total amount of payments he's made minus the reduction in the value of the loan. So to work out the total amount Phil has actually paid, it's 700. It's the payments from the previous question, fortnightly payments from the previous question, which is $1,704.03, times the 78 payments, fortnightly repayments he made over the past 3 years, which is 78. So you do that minus the reduction value of the loan, reduction in the value of the loan. So the reduction in the value of the loan is basically the present value. So how much Phil borrowed minus the value after 3 years. So 350,000 minus the value of the loan after 3 years. So if you put that on your calculator, you should get $45,246.67 rounded to the nearest cent. So that is the amount of interest that Phil has paid. 9c. Over the next 4 years of his loan, Phil will make monthly repayments of $3,517.28 and will be charged interest at the rate of 4.8% per annum, compounding monthly. Let Bn be the balance of the loan n months after these changes apply. Write down a recurrence relation in terms of B0, Bn plus 1, and Bn that could be used to model the balance of the loan over these 4 years. So I've just written the rule for the recurrence relation for a reducing balance loan. So basically, we know that B0 is going to be the value after is going to be the value of the amount of money Phil borrowed after 3 years, which is $262,332.33. This is because it says over the next 4 years, so it's basically saying after the 3 years previously. After 3 years previously, in the next 4 years, Phil will make the following changes to his repayments and to his loan. So that's the initial value, and then Bn plus 1 equals R times Bn. So to find the value of R, we use the rule 1 plus R divided by compounding periods on 100. We know that the interest is charged at 4.8% per annum, so sub R with 4.8, and P is the compounding periods, which we know it's compounding monthly, so you put in 12 on 100. So you put that in your calculator and you would get 1.004. So 1.004 times Bn minus D. So that's the amount. D is the repayments, monthly repayments that Phil makes. So that's actually given to us in the question. It says Phil will make monthly repayments of $3,517.28. So therefore the value of D is $3,517.28, and therefore this is your recurrence relation.